Hello everyone. Am I audible?
Yes, hello sir.
Hello Atreya. So आज का जो सेशन है हमारा Ask Me Anything. We have Mr. Atreya from IIT Madras. So इस सेशन में Ask Me Anything जैसे इसका नाम है, आप जो भी आपके क्वेश्चंस हैं, क्वेरीज हैं, वो आप पूछ सकते हैं अत्रेय से, और ये भी पूछ सकते हैं कि जो इनकी प्रिपरेशन थी उस टाइम पे किस तरीके से इन्होंने अपना प्रिपरेशन किया, किस तरीके से स्ट्रेटजी थी इनकी जिससे ये सेलेक्ट हुए और आईआईटी मद्रास में आज है. सो Atreya, now podium is yours and you can start the session with your journey, and then you can ask the questions and answer round. और सभी स्टूडेंट से रिक्वेस्ट है कि ड्यूरिंग द सेशन हम म्यूट पे रखेंगे आपको. इफ अगर आपका कोई भी क्वेश्चन है देन यू कैन पुट इट टू द चैट और हम लोग उसको आंसर करेंगे आफ्टर द सेशन. सो थैंक यू सो मच. Atreya, now you can start the session.
Thank you, sir.
Yeah.
So yes, hello everyone. I am Atreya Vedantam. I am a student of IIT Madras right now in the branch of electrical engineering. Yeah, so my JEE advanced rank was 315. Yeah. So the point, the thing, I think here I just thought we thought we could have a session where it would be a nice interactive session where I get to know what you guys are all thinking of at your stage in your preparation. So yes, so here so basically I am I'll be discussing a few questions, and I mean if you guys have any questions you can, as Gaurav sir said, you can always write it in the chat box, or you can raise your hand also. I it depends, it's up to you guys. First I'll tell you a bit about my preparation before we begin the technical aspects of the discussion. So a bit about my JEE preparation. I'll try to speak louder. Okay, I'll try to speak louder. Is this volume fine? Okay, fine. I'll speak in this volume. Thank you. So a bit about my JEE preparation. I started my I technically did study JEE topics from 9th standard, as in I tried to prepare a bit higher than school level, but it was only I would say in 11th that I became very serious about JEE, and I decided to really pursue with all my effort and time. So during the course, I mean I as a part of I was a part of IIT. I actually was a part of another coaching institute called Guru, and at the same time I was doing a few modules, and I was trying to self-study as well. I would say a big difference, like a thing that I strongly believed in during my JEE preparation was the belief in exams. As in, I would I would always try not to shy away from writing an exam. That is, irrespective of whether I was, I felt good about the exam, or whether I'd be afraid of getting good marks, or I would always, I'd always give the exam at least, because I think this is an exam is always going to be a measure of my preparation at that point in time. And really, data is what you really need. That's what's going to help you the most. I mean, if you don't write the exam, it's not like you are better, right? Just because you wrote the exam doesn't mean that your preparation was worse, right? The exam is just telling you what your level of preparation is. I think that's the most useful thing that a lot of people can keep in mind. Writing exams is extremely important. I cannot overstate its importance. And a lot of people fail to recognize its importance, and people write very few exams. Exams really give you the experience. Okay, so yeah, that's a bit about that dimension of my preparation. Conceptually, I would say, I think I would stress knowing intuitively, intuitive answers as very important, especially in 11th. I get that as you progress in 12th, and the exam mindset becomes more, and your preparation is more mark minded, right? But I would always encourage, even if you're 11th, right? Especially if you're 11th, where you're learning very intuitive concepts like mechanics, like things which you can actually visualize, right? Not like quantum mechanics or something, like classical physics is something I would say you really need. You really need to developing a nice feel for the answer is good. It's not just about mathematics. It's not about getting the answer really. It's about knowing the answer before you get the answer. It's about knowing that you're going to get an answer around 3 to 5 and then getting an answer, let's say 4. That is really what I think separates a good, a well-prepared aspirant. So yeah, so what else can I say? I mean, do you guys have any questions about this?
Students can ask any questions. Any questions you have? Or you can write the question in chat also. Atreya, you can continue with the questions which you have.
Yes. Okay. I will continue with the questions that was there. Okay. So I guess we'll start with the first question. Can we clear JEE and NEET, or JEE or NEET without coaching? The answer is absolutely yes. There are a lot of people who have cleared. Forget clear. People have topped the exam. People have topped the exam without any sort of coaching. See, in a sense, coaching institutes are just there to motivate you and guide you, because oftentimes the journey of JEE is very difficult and you'll probably lose motivation at a point in your preparation. I know I did, and it took a lot of people to motivate me, to keep me on track. My parents, my teachers, they were all really, they had to, they had to keep telling me, positively, because it's a very difficult thing for me to keep my motivation all through. So I think that's the primary edge that coaching institutes gives. Of course, there is always a huge advantage of the material and everything, but in today's world, there's really there's nothing if you can't get by yourself if you really tried. So answer is yes. In fact, I am not just guessing. I have a friend who's a mains topper. His JEE mains rank was 77. So he's a topper and didn't attend any coaching. So the answer is yes. Of course, that doesn't mean that anybody without coaching can do it. you need to be very smart. You need to be very self-motivated. That's the crucial thing. First, self-motivation is really important, whether or not you're in a coaching institute. Because if someone is telling you to study externally, then you're really not that, you're really not going to be able to focus for that long a period, 2 years, 3 years, 4 years. Because yeah, you'll do it for 3 days, 4 days, but then the fifth day, there's going to be nobody watching over you. Nobody's checking over on like whether you've done your work or not. And at that moment, you're just going to slack off. But if you're self-motivated, then you're doing it for yourself, right? You want the goal for yourself. You want to do JEE extremely well. That's the goal for yourself, right? So why would you lie to yourself, right? Because that's what you want. So I think that's a great thing. So yeah, can we clear JEE? Definitely, right? You need, of course, you need to talk to people about getting to know which books are good for solving, which material to get, what kind of, where to learn concepts from. There are lots of videos on YouTube or things like that where you can learn concepts, but you have to be smart about that. You should. So yeah, it requires a little bit extra intelligence. It requires a bit more thinking on your part, because a coaching institute will just eliminate the thinking on your part. It will give you the material ready, but it's definitely possible. Okay. In the last 25 days, solving JEE advanced previous year questions as a mock test is beneficial, or should I go for coaching institute test series? I'm currently giving Allen mock tests, but I find its questions on the tougher side. Okay. Okay. So one thing is, solving previous year papers is an extremely important thing. I think it is, if not the most important thing, one up there. Okay. Because the experience that solving the past year papers gives is really unparalleled, because those are really just past year JEE papers, right? So those are papers which are actually students wrote, and they were like the process of JEE happened to them too, and that is a real paper. That kind of experience really cannot be simulated by any other mock tests. Allen mock tests are great. I personally have given them, so I know that their questions are of really high quality. They're actually quite hard as well. I would recommend giving them, yes. But if your question is or, then I would definitely say go for JEE advanced past year papers. JEE advanced past year papers are must, I would say. It's a huge advantage. Those who have done JEE advanced past year papers have a huge advantage to compare to those who didn't, right? The one reason being is experience, and the similarity in type of questions. Allen questions are quite hard. I would say most questions are harder than JEE advanced level, and they're very useful. So in a sense, if you're finished with JEE advanced papers, I would definitely recommend doing Allen tests, because Allen tests or even FITGI tests, because they're also everyone was FITGI AATS is quite hard. And that's not because they're going to really simulate the JEE advanced experience, because they're going to be much harder, right? You're going to get lower marks than you would in an actual JEE paper, but just to test your mental strength, whether you can really handle not getting questions in the exam. That's an important skill to have. In the exam, you should be able to handle a situation where you don't get any question in the exam calmly. That really will help you in the exam, because if you freeze, if you get worried, oh God, I'm not getting 6 questions, then you're not going to do the rest of the exam well. Maybe after the 7th question, you're getting a lot of questions right? Who knows? So that kind of balanced approach is better developed through tough exams like Allen or FITGI AATS. But a definite essential component is, I would say, JEE advanced past year papers and JEE advanced past year questions as well. So it's up to you to split up. So there's a vast history of questions, right? It's up to you to split up which years you're going to write as papers, and which years you're going to write as solve as questions. So that's up to you. So yeah, any other okay. Fine. I'll just go to the next question. Well, there are a few technical questions now. So how about I share my screen? Would that be fine? I will share my screen. Yes. Can you see my screen? Yes. Okay. So yeah. Okay. Well, the first question is what is the relationship between electric field and electric potential? So this is a good it's a fundamental question. It's important to know, right? But the important thing to know is the of course the definition. So what's electric field? Sorry, I don't know what's. So yeah, that is the definition of electric field. Note that electric field is it's an inverse square law. It looks like a cube, but I'm writing r vector by mod of r cube, and potential is a scalar. It is 1 by 4 pi epsilon naught q by r. So that is potential. I think a lot of people already know this relationship. E is equal to minus dv by dx, right? This is in one dimension, assuming electric field, assuming one-dimensional fields. So yeah, this is the relationship between electric field and potential. I mean, you can always integrate it and write integral EDL. So another way to write this integral EDL, E dot dl is integral E dot dl is the potential drop. So minus delta V. Potential drop is the negative of the potential difference. So yeah, either of these relationships, they're essentially equivalent. You see, one is just the integral form of the other. So electric field and electric potential are related this way. So I'll just go ahead with the next couple of questions. Please explain projectile motion. Okay. So projectile motion is it's an important concept, a very fundamental concept in kinematics. So what is a projectile? So clearly you can, from the name, you can see that it contains the word project in it, right? So what's project? You immediately, when you think of the word project, what comes into your brain is like throwing a ball, right? So yeah, it's exactly that. So you throw a ball. Projectile motion has to do with the trajectory of the ball. The trajectory of the ball is, roughly speaking, the path taken by the ball in space. Why do I say roughly? Because trajectory is not just the path. Trajectory is the time dependence of the path. Basically, it's how the path varies over time. Basically, it's r of t. This is called the trajectory. Remember that this is not the path, because it is possible that two different trajectories can lie along the same path, but they just are at different points in time, right? So r of t, the trajectory is really the encodes all the information of the ball. Now, projectile motion. So how do we analyze how do we find out the trajectory? That's a good question. How do we find various aspects? Like what do you think, how do you find its range? I mean, this is a big thing. So I'm not gonna go into much depth. So how do you find a maximum height? So that's represented by capital H usually. The distance between the point of projection to where it falls is called a range. And then the angle of projection is often called, it's called theta. I mean, often it's designated by theta. Yeah, there are a bunch of things you can estimate about, you can estimate the trajectory. So exactly. So you can estimate R of t. You can estimate a couple of things. So if you want, so how do you get about deriving? So because I don't have time for deriving everything, I'll just give a brief outline of how you might approach, right? What kind of equations might you use to derive different kinds of things? So in any problem, right? Whenever you're faced with a problem, a JEE problem will always be a statement in English, right? It'll be or Hindi or whatever language you're taking the exam in. It'll basically be a statement in non-mathematical terms. So it'll be a statement like a ball is thrown in the air, and then you'll be given a couple some mathematical data naturally, right? For quantitative analysis. So it'll be thrown up with 20 meters per second. Find the time taken before it comes back to the same point. So basically, you have to convert this English statement into a mathematical equation, right? So whenever you think about that, think about the problem as a situation, right? A situation that you're placed in, and you're given a constraint. The constraint in this case is a ball being thrown up on Earth. Why is Earth the constraint? Because Earth has a constraint of acceleration due to gravity being 9.8 meters per second squared downwards. Right? That is G. So that is acceleration due to gravity. That is a constraint. What is a constraint? Constraint is anything that's preventing you from making free assumptions, right? So you really can't assume G to be anything else because you're on Earth. What is the second constraint? The ball is thrown up with 20 meters per second in the example that I said, right? So yeah, so basically, okay, yeah, I think I'm dragging it a bit. Conclusion is, you're given a couple of constraints, you're given a situation, your idea is to find an optimal solution to the system. Okay, that is what you should think about. So in this case, I am projected with theta. So let's say let's say my initial velocity of projection is v. So you can obviously resolve the vector into its components. It's v cos theta horizontally and v sin theta perpendicularly. And the most important thing of most important concept of projectile motion is that the horizontal and the vertical components are independent. That's literally the only basic fact that you need to know. And if you think about it, it's not very obvious, right? Why it should be, but a bit more thought will make it obvious to you. But with this essentially means that you can analyze the horizontal and vertical motions independently. That means your x will always be v cos theta into t because there's no acceleration, and your y vertical will all naturally be y is equal to v sin theta t minus g half gt squared. I'm not going into all of that. Okay, basically, I think you already. I think this is available anywhere else. Okay, so the next question: in order for the heat to flow from one part of the solid to another part, what is required? Very good question. Intuitively, you know that when two bodies are at the same temperature, there's going to be no heat flow, right? If you are if you're pretty cold and you go out in the hot weather, your temperature will increase. So it makes sense that equilibrium is achieved when temperatures are equal, right? So that's the answer essentially. If heat has to flow from one part of the solid, let's say this is a solid. If heat has to flow from one part of the solid to another, then there has to be a temperature difference. I'll give you a very nice. I think this is very well known, but I'm just reiterating. Well-known analogy between heat conduction and current transfer. Right. So what is the law that governs heat conduction? H. That this is called the Fourier's law of heat conduction. H is equal to Ka dt by dx. dt by dx is a temperature gradient. Okay. So H is the heat transfer per time. That's important. So heat transfer per time plays the analogous role of current in a circuit. K is called thermal conductivity. Okay. And you know that resistance is equal to rho L by A, right? This is a formula that we know. But you know that rho is 1 by conductivity, right? Into L by A. So if you think about it, this formula looks very similar to this formula. You see Ka d by dx. So in fact, that's not a coincidence. So Ka d by dx, if you take this side, right, that plays the role of resistance, and dt plays the role of potential difference. So that is the connection between Ohm's law and Fourier's law of heat conduction. It's a nice thing to know. So you naturally know that when heat is flowing, it means in your mind current is flowing equivalently. You can construct an equivalent circuit which does the same thing. Potential difference is represented by a temperature difference, temperature gradient. So you see that if current has to flow between 2 points of any circuit, you know that there has to be a potential difference, right? Analogously, that corresponds to a temperature difference here. Okay, we'll go to the next question. I think we'll go slightly faster. How can we find the number of moles from Cp and Ce values is the next question. To the best of my knowledge, we cannot. Why? So we know that Cp and Cv are molar specific heat capacities, right? Sorry, molar heat capacity. So molar heat capacity at constant pressure is called Cp. It's represented by a bar because it's molar. Cv is molar heat capacity at constant volume. These two are intensive properties. What does intensive mean? Intensive mean does not depend on the amount of substance. So that's the definition of intensive properties. So clearly, if you're given an intensive property, if it doesn't depend on the amount of substance, it does not depend on the number of moles, right? That's what it equivalently means. So how can you find the number of moles given Cp and Cv? You can't, because since it doesn't depend on number of moles, the number of moles doesn't depend on Cp and Cv. So given Cp and Cv, there's no way you can find out the number of moles. So that's a way of arguing. Okay, next question. What is the molar heat capacity of a monatomic gas for the process P is equal to constant? So this is simply as discussed before. This is the heat capacity at constant pressure, which is 5/2R. If you want to know why, you need to use the first law of thermodynamics, and basically you take a constant volume, constant pressure process, right? In a constant pressure process, work done will be P into delta V because pressure is constant, right? So the derivation is pretty simple after that. So okay, what is the heat energy of? I'll go to the next question. Heat energy of I'd say H. I don't think it's given. Okay, heat energy of H is given to a diatomic gas. Is given to a diatomic gas, allowing it to expand at constant pressure. Okay, so it's allowed to expand at constant pressure. Okay. So it's allowed to expand at constant pressure. Each gas molecule rotates about an internal axis but does not oscillate. So basically it's a diatomic molecule, right? So gamma is 7/5. What is gamma? Gamma is called the adiabatic constant. Okay. So the adiabatic constant for a diatomic gas is 7/5. If you're wondering where that came from, it's a bit difficult to explain. I mean, gamma is defined as a ratio of the molar specific heat capacities at constant pressure and constant volume, which happens to be 7R/2 by 5R/2. Okay. Again, this derivation stems from the first law of thermodynamics. So basically, the diatomic gas allowed to expand at constant pressure, and the diatomic gas also rotates around an internal axis. So there is an internal axis. So what I don't know exactly what they mean by the internal axis of the molecule. I think it's probably this molecule. It rotates about this axis, but it does not oscillate. So this is a very Yeah, this is an interesting question. It's a little ambiguous if you think about it, right? If they so the basic concept to consider here is the number of degrees of freedom. So given a heat h, right? Given a heat h, q is equal to delta U plus W. That's the physics first law of thermodynamics, right? Given that work done in expansion is positive by a substance. Delta U is obviously is always NCV delta T, right? So that's 1 into it's allowed to expand at a constant pressure process, but doesn't matter, right? It's still 5 by 2 R to delta T plus W. This is a work done, right? Uh, oh, wait, sorry, my bad. 1 second. So, okay. So heat energy is given to diatomic gas. So, okay, what does okay. So since it's allowed to expand at constant pressure, you know that Q at constant pressure is given by NCPD delta T, right? This is equal to H. So of course we don't know this is 7 by 5. We'll keep it on the hold because 7 by 5 is for a general diatomic gas. Here we're given constraints. So how did the 7 by 5 come from? Is actually by the number of degrees of freedom. Okay, so it comes from equipartition principle, which states that every degree of freedom gets half kT of energy. Okay, so okay. The point being here is we have to count the number of degrees of freedom. So the number of so basically CP will simply be n plus 2 by 2 R delta T. Okay. Similarly, we know that delta U is always NCV dt, right? Sorry, so this is a bad choice. We'll call it F. Okay, degrees of freedom will be F n F by 2 R delta T. This will be delta U. So clearly, upon dividing, right, H divided by delta U is simply F plus 2 by F, right? Now, what is F? So we know that a diatomic gas can translate in X direction, the Y direction, or the Z direction, right? So X, Y, or Z. So notice how I have drawn it wrongly. This is not. This is why do I say wrongly? Generally, all of our coordinate systems are right-handed, which means I cap cross J cap should be K cap. So this should be X, Y, and Z. Anyway, point being, it has three transition degrees of freedom. Right? Now we need to count how many rotational degrees of freedom it has. Clearly, it doesn't have any vibrational degrees because apparently it doesn't oscillate, right? So how many rotational degrees of freedom does it have? Now it depends on the interpretation of the question, unfortunately. If you assume that it is a fixed internal axis, which is not along the principal axis of the molecule, right? If you assume the axis looks like something like this, then there is going to be 1 degree of freedom that's going to rotate around this, right? So you're going to add 1 more to this. So F is going to be 4 then. So that's going to be 4 plus 2 by 4. However, if the fixed axis lies along the diatomic molecule, then it's the rotation along that line is negligible. It doesn't contribute energy. So it's only going to be 3 plus 2 by 3. Okay, so that's up to interpretation question. So I'll just leave it here. Anyway, so the next question is, a flask contains hydrogen and argon by the ratio 2:1 by mass, right? So I just like to instead of dealing with ratios, I just like to assign numbers to stuff. Well, you know that argon has an atomic mass of 18. So let's just say let's say you have 18 grams of argon, which means you have 36 grams of hydrogen. This means you have 1 mole of argon, and you have 18 moles of hydrogen, right? We'll see if it's even useful calculating number of moles. The temperature of the mixture is 30 degrees Celsius. What is the ratio of the average kinetic energy per molecule? So what is average kinetic energy per molecule? It's a very interesting question. So this is a lot of people have this confusion. So I'd like to take some time to explain. A lot of people, some books say K is 3/2 R. We'll deal with Boltzmann constant, okay? Per molecule. Everything is in per molecule. R equivalently for per mole. Okay. I think somebody accidentally drew something. I will delete. Okay. So anyway, as I was saying, some books say K is 3/2 R 3/2, and some books say F/2 RT. Well, this like a lot of students face this confusion. I face this confusion too in my JEE preparation. The answer really is that these two are talking about different things. This is talking about only translational kinetic energy. This is talking about the total kinetic energy. Total kinetic energy includes vibrational, rotational, etc. So translation is only 3/2 kT because there are only 3 degrees of translational freedom. Whereas there are 3 degrees of rotational freedom and who knows how many modes of vibrational freedom depending upon temperature. So that's a separate thing. So in this case, we are asked to find the total kinetic energy per molecule. So we'll be using this formula. So therefore, the average, we just require the ratio of the kinetic energies of argon and hydrogen. So we really don't even care about the RT because the temperature is same for the mixture. Because the temperature mixture is the same, right? So we don't care about the temperature. We don't care about gas constant is universal. Factor of 2 gets cancelled out. So we're really just interested in the ratio of degrees of freedom. So how many degrees of freedom does a monatomic gas have? 3. How much does a diatomic gas have? 5. So the answer simply turns out to be 3/5. Okay. So the force between two charges when placed in free space is 10 newtons. Whereas what is the force between the two charges if it's immersed in the medium of dielectric constant 2? It's a very good question. Again, it's unfortunately slightly ambiguous. I think I can understand the meaning. I understand the what they want to convey. So the question really asking is, if in free space the force between two charges is 10 newtons, right? Forgive my plus, it looks terrible. Would it still remain the same if there was a dielectric medium, right? If it is polarized. I mean, if it is a dielectric medium. So dielectric medium, you know that when in the presence of charges, they get polarized, right? So let's just briefly draw how they get polarized. It'll help us give an idea. I mean, one thing is like as JEE aspirants, like you should definitely know this answer straight away. If the dielectric constant is 2, then the net force experienced by a charge is F/K. So notice the words that I'm using carefully. The net force experienced by a charge will decrease K times. So it will become 5. However, what we are asked to find is the net force between the two charges. This is a mistake that a lot of people will make, right? Force between two charges is simply 1/4 pi epsilon naught Q1 Q2 by R squared R cap. That's it. force is a vector. So that's it. It's not, there's no dielectric here. The dielectric is only comes in the net force, because the medium is going to influence the net force. Medium is going to have its own forces because of its polarization. See, it's going to get negative charges are going to pile up here, plus pile up here, plus piles up here, minus piles up here. It's going to have a net effect on both charges. In fact, it's easy to see that the net force reduces. Look at these negative charges. They're going to strongly attract a positive charge in this direction. Look at these positive charges. They're going to repel these positive charges. They're going to repel the positive charge, but slightly less, right? Because they're further away. Similarly, these negative charges are going to attract even slightly lesser. So you can see the overall effect is towards this side. So you see that the 10 is going to be reduced. So it's going to be reduced by a factor of 2. Okay. So the net force is decreased. However, the force between the two charges is always 1 by 4 pi epsilon naught Q1, Q2 by magnitude of R squared R cap, where R is a separation vector. See, notice that you have to be very clear when you're talking, right? When you're talking about a vector, when you're talking about a direction of the force, right? It's good to say, it's fine to say kq by R squared. I used to say that many times, but I find a certain, a methodical way of approaching problems when you write down these details like these vectors. Okay. Anyway, that's a personal taste, and JEE, if you're short on time, I really wouldn't recommend. I think this is more than enough. Okay, so yeah. Anyway, so the next question is, two positive charges, 16 and 4 coulombs, are separated by a distance of 3 meters. What is the electrostatic force of repulsion between them? Again, this is a simple problem. 1 by 4 pi epsilon naught, everybody should know this value is 9 into 10 to the power 9. Okay. It's not exactly, it's a very good approximation. This approximation is something everybody should know. Okay. Like there are approximations that everybody should know about. In modern physics, there are a couple of approximations with respect to the conversion between electron volts and joules, etc. The people should really know h times c. H is a Planck's constant and c is the speed of light. Right? These kind of useful things. People should know Rydberg's constant. I think everybody will know. Right? People should know the gas constant. A useful approximation is 25 by 3. These kind of tips and tricks, they're just going to help in calculation. Okay, especially in JEE main, where the exam is extremely calculus intensive. So you have K, Q1 is 16, Q2 is 4. The distance of separation is 3 squared 9. We need to calculate the electrostatic force of repulsion. So unfortunately, we are not given directions, so I'm not going to specify directions, but always please be careful that force is a vector and there should be a direction associated with it. Okay, I'll just write R cap right now. So the 9s cancel, so it's just 64 into 10 to the power 9 newtons. This is an extremely high force, which is why you never see charges of this magnitude, 16 coulombs. That's a crazy high charge. You only see things of the order of microcoulombs, right? And you're dealing with circuits, I'm sure with capacitors, you would have seen that capacitances are of the order of microfarads and voltages are of the order of volts. So that would mean that charges are of the order of microcoulombs. Anyway, this is also a useful thing to keep in mind. Okay, whenever you're doing JEE problems, always have a sense of order of magnitude, have a sense of whether you're in the right range of answers. You shouldn't end up with 10 and answer answer being 10 to the power 10. Okay, that's bad. You should improve your sense of numbers. Even if you don't get the answer, let's say you get 10, answer is 12, that's okay. That's something you can slightly work on. But at least have a sense of the magnitude of number. That really will tell you whether you're in the respective concepts. Your concept will be in the same order of magnitude, barring any calculation mistakes, of course. So that's an important thing to keep in mind. Yeah, the next question is, an electron revolves 6 into 10 to the power 15 times per second. Revolves around some circle. Calculate the current. Calculate the current produced. So if you really want the answer is, this is current is undefined. Okay. But this is a true physics answer. Okay. This is the actual one. But since you guys are preparing, like at the GE level, you would just say this Q by T, and where Q happens to be the electron that's revolving. This is small. This is not really right, but we will talk. We'll just go with it right now. What is T? It revolves 6. This is a frequency, right? Frequency is 6 into 10 to the power 15, because it's revolving that many times per second. So time period is simply going to be 1 over that. So that's a very simple calculation. You're going to get 9.6 into 10 to the power minus 4 amperes. So that's a small current. Yes. See, I'll tell you why it's undefined. Okay. So do you think that an electron moving straight upwards at a very high speed, let's say, is equivalent to a current moving downwards, let's say, for the sake of being consistent? When an electron moves upwards, it means that positive current is going downwards. Is that true? Answer is wrong. Definitely not. Because if you look at the magnetic field due to this current, you basically integrate the Biot-Savart's law from minus infinity to infinity, right? Because currents are continuous. Electrons are always moving. However, here there's only one electron moving. If you were to calculate the magnetic field at this point, you would only have to do QIDL cross B. So you see the cross product here. So this will be the R vector in this case. In that case, this is the, let's say, direction of velocity. That theta. So you'd have to do that sine theta business with the cross product. Whereas here you're not doing that, because all of the integrals simply add up in the outward direction, right? If you look at the it add up in the outward direction to give a nice, pretty neat answer. However, this is not the same case, right? The magnetic fields are clearly different, which means they're not equivalent in all senses. So similarly, something going around in a circle, an electron going around in a circle, does not equivalently constitute a current at all. However, for the sake of whatever, we just go with it, because it's pretty obvious that that's what they want us to do, right? Okay. We'll have the next question. Why is density used instead of radius in Gauss' law? Actually, I really don't understand what that question is asking. What do you mean? Why is density used instead of radius in Gauss' law? Actually, an interesting question I have is, how do you know that density is used? So by density, of course, I think you mean charge density. How do you know that charge density is used in Gauss' law? As far as you guys know, I think Gauss' law is simply the cyclic integral of electric flux around the surface, around a closed surface, is the charge enclosed by it divided by the permittivity of free space. I think that's what you guys know, right? This is the Gauss law, right? Later, you will learn a different law, okay? Which, okay, I will tell you. Okay, but this is something that you do not know yet, because you do not know what this is. Okay, I will not bother mentioning what this is either. But this is where charge density pops up. Okay, this is also Gauss law. Actually, it's just a differential form of Gauss law. But I'm not going to go into that. The point is basically, as far as you are concerned, as far as JE is concerned, there is no charge density anywhere. It's just a charge enclosed within. Okay, so I'm not sure what that question means. So I'll just leave that question. Interesting question. I think it's a small break from heavy calculation. I mean, what do you think? how do you know? I don't know the answer either. Let's say I don't know the answer. What would I do? That's an important thought process to analyze, right? So what I would do is, the question asks me for what factor is responsible for cutting an apple, pressure or force, right? So what I would try to do is simulate a mental experiment to differentiate between the two. Can I mentally simulate an experience? Yes. Let's say I take an apple, I take a knife and I cut it. I think I can cut an apple with a knife. Let's say I try to apply the same force that I'm applying with a knife with my hand like this. Do you think it's going to make any difference? Not really. I mean, if I try to squeeze it very hard, I think something might happen. I don't think I'm that strong though. But it's pretty obvious that a knife will easily cut through, whereas the hand won't. And that clearly just goes on to tell us that pressure is what is really causing cutting rather than force. Now, why should this be true at a fundamental level? At a fundamental level, if you think about it, any breaking process is a breaking of bonds between two atoms. So let's say you have atom AA, you have a bond. The breaking of this bond is really what is contributing to the cutting process. So this is going to be the cut part A, this is going to be the cut part B, right? If this bond is broken. So let's say that the breaking of the bond has a constant force to break, which is F. Okay. Now you'll have one more bond, and that force will also have a breaking force that necessary is F. You have one more bond, and that force required to break that is also F. And on and on and on and on. You can automatically see that if you have n such bonds, then the force required to break the system is n times F, right? So you automatically see that the more bonds you have, and you know that the more bonds essentially corresponds to more surface area, right? Because more the surface area you have, more the number of molecules you have in that cross section. So this is proportional to area, which means since this is the factor that really is breaking the material, the factor responsible for breaking the material is simply F by A, which is stress or pressure, right? So therefore, it's not force which is breaking an apple; it's really the pressure, stress, or the pressure which is cutting an apple. So there's a bit of elasticity, yeah. Okay, then you have another question. The effect of gravitation is seen more on liquids than on solids. Why? I don't think that's true. I just leave it at that. I maybe you're meaning it. Maybe the question is in some context that I do not know. But as far as I know, there shouldn't be any difference between the way liquids react to a gravitational force and the way solids react to a gravitational force. So, okay, I'll just move on to the next question. A body starts moving with a 2 meters per second squared acceleration. 2 meters per second squared acceleration after starting from rest. So it starts at rest. So you see an important thing to do in every physics question: draw a diagram. That's a very important factor. Draw a diagram always. Okay. Every physics question, you should draw a diagram. If you don't know anything about the question, draw a diagram. A diagram will really help you simplify a question to a big deal, to a great extent, I mean. Okay. So, okay. So, okay, fine. So I'll go a little fast now. So the distance covered in the 5th second will simply be the distance covered in 5 seconds, which is half into 2 into 5 squared, minus distance covered in 4 seconds, which is half into 2 into 4 squared, which is simply 25 minus 16, which is 9. So that was a simple question. A 100 kg golf ball is moving to the right with a velocity of 20 meters per second. It makes a head-on collision with 8 kg steel ball initially at rest. Compute the velocities of the ball after collision. So that's a very, very interesting question. I don't see where you get a 100 kg golf ball, but whatever. So you see 100 kgs here, moving at 20, right? This is steel 8 kgs at rest. So you write 0. Then you write V1 and you write V2 after the collision. Write V1 and V2 in the same direction. Okay. If V1 happens to be negative, it just means that V1 is in the other direction. So that's a important thing to keep in mind. Mathematics always takes care of itself. Okay. So first, conservation of momentum, 20 into 100, 2000 is equal to 100 V1 plus 8 V2. That's the first equation. The second equation is simply the coefficient of restitution, the relative velocities of separation divided by the relative velocities of approach is minus E. In this case, it's a, well, they didn't mention, so I'll just assume it's an elastic collision, okay? Or I'll just assume it's a perfect inelastic collision because that will make life very simple. Yeah, for a perfectly inelastic collision, coefficient of restriction is 0. So V2 is equal to V1, which means that 108 are just sticking together. So the combined velocity will simply be 2000 by 108 meters per second. So that's the question. Then okay, then we have the last question remaining. So the last question is a very interesting question. So the last question is, two identical small bodies have mass m, charge q, suspended on a string same length L from a fixed point, let's say P. It is now taken in some artificial orbit around the Earth. So this is the Earth. Find the tension in the string, right? So what you're going to do is for this mass m, you're going to see that the force, let's say the separation is going to be theta, right? So you know that this is 2L sin theta is the distance. So the force is going to be k q squared by 2L sin theta the whole squared. Of course, I'm representing the direction as that's if I'm not writing the vector as a whole. And you know that the gravitational force is going to be gmm by r squared, where r is the distance from the radius of the Earth, right? And you know the tension is going to be T. And you know that the sum of all of this is going to lead to a centripetal force of mv squared by r downwards, right? So in other words, you know that T into sin theta equals kq squared by 2L sin theta the whole squared. That's one equation. The second equation is gmm by r squared minus t cos theta is equal to mv squared by r. However, I believe in this question is incomplete in the sense that they should have given more additional information. They should have given more information about what kind of orbit it is. Is it geostationary? That's something they're not mentioned. I think without that you can't solve this. You don't have sufficient information. So anyway, yeah. So with that, I'd like to stop because we have covered all the questions for the session. All the session. If you have any other questions, go ahead.
Thank you so much, Atreya. Thanks a lot. It was a very nice session, and thanks for your time. Thank you.
Thank you, sir. Thank you, sir.